hello everyone. My name is Daria. I'm from Novelties, and well, today I'm here, as already been said, to present you a QGIS exercise dedicated to impacts of climate change on freshwater resources with sentinel-2 imagery. So for this tutorial, we decided to focus on one specific area in southern Spain, because, well, southern Spain is one of the regions in Europe which is mostly exposed to the effects of climate change, and specifically to the effects of climate change on water scarcity. And, well, I don't have much time to give you all the context, but we decided to focus on the Doñana National Park. It's in southern Spain, not far from Seville. And here on the slide, you can see a little image, which is a bit sad, honestly, because here we can see a photo of Zailio Pond in this national park, and we see this one image, like a photo on in the middle. It's a photo of this pond in June 2011. And the photo below is in October 2022. And you see that, well, in the first photo, we see water. And on the second one, we see basically nothing. It's just a field. And it's quite sad. And on top, you see a small image, a small plot with depth of this lake, this pond, from 1994 till 2022. And you see that, of course, it fluctuates. Yeah, it's also wetlands, but wetlands doesn't mean that it's the lakes, the ponds there doesn't mean that they always are full, always like deep. It's quite shallow lakes by their nature. But you see that with time, we have a very, very low values of depth, and sometimes, well, we see that it goes more and more below this red line, which marks the bottom of the pond. So for this exercise, for this tutorial, as I said, we will use sentinel-2 imagery, and most precisely, well, we will use this product from WEkEO platform. And we downloaded only NDWE product. I will show you very quickly. Well, I need to identify myself. Oh no. Yes, okay, great. So you can choose a product here, and yeah, we were looking at water index because we're more interested in water index to see the the freshwater sources. So in this product, there are only bands that are used for water index calculation, which is band 3 and 8. And the second product we're gonna look at is this EU Hydro river network, which has basically, you can actually see it here on the WEkEO platform with all the rivers, with all inland water and coastal water as well. So let's go straight to the project itself. As I don't have much time, I'm not gonna be very in detail. The step-by-step procedure is explained in the video and in a PDF file for this tutorial. And well, quickly saying about the exercises. So first is to work with satellite imagery. So each image is represented as a raster tile. And what we downloaded basically two tiles. So our zone, I will show you very quickly without. So this is basically, you can actually see the national park. Basically all this zone, here you can see the river. Here's some quite strange, well, it is water, well, depends also on when this image was taken. Also water here. And to cover this zone, we need two tiles with SQA and SQB of T29. So we downloaded two tiles, as you can see, for 2018 and 2022. Like, we wanted to see what's the change between two dates, because we know that, for example, in 2022 was a very, very hot year with a lot of heat anomalies. And here, for example, you see the band 3, as I told you, and we also have band 8, which is a bit in different colors. And they have the same for 2022. I will not, I'll show it like this, you see. And well, we download two separate tiles, and for our further calculations, we wanted to have like basically one big one. So for that, we merged our tiles. So for example, we have one merged one for band 3, and the same for band 8, and the same we have here for two bands for 2022. And to merge, we use, well, we go to processing toolbox here. If you don't have it open, well, it depends on your QGIS settings. If you don't have it, you can see it. Well, my Zoom panel covers it, but here on top there should be a little. It's here like this gear icon that gives you access to this toolbox. So when you search for merge, you can see merge vector layers. It's here in vector general, and here you basically choose among layers which you want to merge. Sorry, actually, no, I went a bit too quickly. It's not merge vector layers. We work with rasters. It's this one. Sorry, there are two different tools. So this one, yeah. Here you choose raster layers, and then that's basically it. It just merges it, and also rescale to unify the scale bar. After that, well, you see that it's a big image, and as it's a raster image, it's a Sentinel 2 image. It has a lot of pixels. It has quite a high resolution. It also means that it is bulky. So to process it further, we would like to clip our image to the only area of interest, so around this national park, because otherwise, like even with this amount of information, it already can some processing can take time, and by clipping, we actually reduce this time further. And also, yeah, we just don't really need anything else, any other areas. So for that, we have it clipped. For example, let's see. Okay, so we just clipped this. It will load. It just needs a bit time. Yeah. So original image was this. Yeah, you don't see it, but because it's the same area. But yeah, you can see that when we clip it, it is a smaller area. We could even clip it even smaller, but we decided to stay on that. And to clip, there is also a clip function, and there's also for vector, which is important to not to use for rasters, and one for raster, which is, I think it is which one? Clip raster by extent. Yeah, this one. So here you choose the layer. For example, we choose the merged one, and then clipping extent. You can either use some map canvas extent or just calculate it from layer. You see, like we're proposing layers you already have, or you can literally like choose it yourself, like type it yourself. So after we did that, we now have our clipped layers for both 2022 and 2018 for both bands 8 and 3. And next is, of course, to calculate the water index, which is band 3 minus band 8 divided by band 3 plus band 8. I hope I did not miss. Yeah, I think it's, yeah, minus on top and plus, yeah. So, and for that, you can use raster calculator. You can put calc, and there's raster calculator function, which is here. You can put an expression, and you can choose it yourself, like this, blah, blah, blah. Or we also provided it with, I will show you, it is provided in a PDF file we are giving to you. So that's a formula we used. So we have band 3 minus band 8, and all that divided by the sum of these two bands. And we also added the condition more than 0, because for water index, basically the pixels that are having values, well, the pixels of water index that are having values more than 0 usually represent water, and when negative ones or very close to 0, they are representing something else. So like this, we just did 2 steps. We calculated NZWI and also filtered it to have a binary representation. And as a result, we have this image. So as I told you, you see we have basically in black is whatever it is, and in white is all possible water with like sea and stuff. And we did it for both years, and even if we just compare it visually, we already see that in 2022, I will zoom a bit. In 2022, we already see that the amount of white pixels, it has reduced. You see that there are less pixels. And more importantly, we know that here there's this national park. And if we look at 2022, well, it's not like we really see water there. And in 2018, we see all these little ponds, lakes, the wetland itself. Next, what we want to do is to find more like, we visually detected that there were less water in 2022 and 2018, just in 4 years. We wanted also to have evaluation more like in quantity wise. So for that, we need to calculate the area of this water present, water surface. But for that, first we need to vectorize our raster image, because this is still a raster image. So if you really like zoom in, you'll see that it's pixels. And we need to make it like transfer to polygon to make it vector. And for that, there is a tool here in this tab, raster conversion polygonize. Here you choose your input layer, which is raster. Then you, yeah, these two are not very, very important, and you save it as a new vector layer. And for example, we look at 2018, and we see now it is not a raster, like it's not an, I will untick this one. It's not a pixel. You see that it's a polygon, like this one is one big polygon, this is another polygon, and so on. And it is already filtered. You can see that there's a filter to basically show only water, because we are interested in water index and water bodies, so we don't need really the full image. But if, for example, we click on this filter and we remove this filter at all, we will see that it's exactly the same kind of like we had a raster image, and it just transferred it to polygons. And yeah, you also might see that it's half transparent kind of, because we reduce the transparency to have a better view here. So that's basically it. And I will right click, go to filter and put up, no, not this one, sorry. Okay, I think my QGIS, yeah, okay, well, we need to wait a second because it's a bit, yeah, it doesn't like something. Well, the thing is that before we moved to see the difference between two, we wanted to calculate the difference between the two dates, the water index of two dates. We need to fix the geometries. That's very important because, well, we see that it's something is good and a layer is completely okay, but some, okay, it's finished. But it's only for our eyes, but not always for like the processing itself. So we need to fix the geometries, which you also can do here by putting fix here. You just fix geometries, basically like removes all the instabilities, let's say. Okay, I'll just filter it very quickly. Okay, and after this, after the geometries are fixed, we can have a difference, which we calculated already. This one actually takes a lot of time because there's a lot of small polygons which were going to be compared to each other. And this is basically made by using symmetrical difference tool. Don't remember where's the, okay, it's here. So basically you choose two layers, vector layers, to overlay them and to see, to basically symmetrical means that it extracts the portions, like it's written here, or features from both the input and overlay layers. They do not overlap. So basically that the parts, for example, here you can see all the polygons that belong to 2018 but don't belong to 2022. So basically exactly the difference, which means that all these water polygons we see here, they disappeared by 2022, or at least that's how Sentinel imagery, Sentinel-2, says it, because of course depends on the quality of the image, quality of the water, if like some turbidity or some whatever. Of course, there might be still some water, which just the way satellite sees it, it's not exactly, well, it doesn't see it as water. And here in the difference, if we right click and we go to open attribute table, we see an area column, which we added by using this field calculator function. And here you can see the area in square kilometers per polygon. It was sorted from biggest to smallest. You see, for example, that biggest one area like 8 square kilometers. If you right click and flash feature, you will see which one, and it's this one. But that doesn't really give us much representation because, well, it's just each small polygon having its own area. And to have quickly have like a sum of all these areas, we can go to sorry, I think it's view panels. Yes, view panels, and we have statistics. This one. And here you can choose the layer you're interested in. Because we already were looking at this one, it automatically chose this one. And also area, you can choose all different fields, but we are interested in area. And you can see the mean, median, maximum, minimum as well. But we are interested in sum. And here you see that it's 65, a bit more than 65 square kilometers, which is just for the scale, that's around 9,000 football fields, which is quite a lot. And that means that all these 65 square kilometers of fresh water in this national park disappeared in 4 years. And it's also important to note that this wetlands, this national park wetlands, there is actually quite important ecosystem in whole Europe. It's a home to many animals, many species, which are also endangered. So well, you see that that it's kind of how entangled all that together. So that was for the imagery. And as well, we wanted to see a second product, as I told you, is EU Hydro River Network, which is basically kind of a base layer. So it's a delimitation of water bodies. And we used in this tutorial, we use it more like as reference layer to say like, okay, what it could be with all the water present, let's say, and to compare to what we have in 2018 and 2022. And of course, with this delineation, it's quite, well, it depends on when it was taken. It's quite, how to say, like generalized. So it's not a very like exact representation. I just wanted to see like correlation between the two. So when we added those, this new product, Hydro, it's these three. Actually, when you import the layer, it has many layers, but we only like sub layers. We chose only 3. So pink is inland water. Yeah, green is some river network, and purple is transit, which basically means that, well, it's still water, and you can see that it's a river, but it also means that the flow, the level, water level in this for this transit water depends on the tides, because, well, it's on the coast. So after we had it all free, we merged it to have one layer, basically, because we needed to like more clear representation. And so that we used this tool, which I already showed you, merge, but for vector layers now. And then if you zoom out, you see that it's actually the whole, not Spain, it's the whole river basin of this river. And we're not interested in that. So we clipped our zone only to that, you see. It's only in green, but are more in our area of interest. And to that, yeah, you clip by extent, basically the same as we did for raster, but now it is extracted by extent for vector layer. And if you click on it, you can have an extent which you can put yourself, but we also chose an extent which we computed from one of the like water indexes layers. And that's it. And we wanted to do exactly is to see the overlapping of this EU Hydro product with Sentinel-1. So Sentinel-2, sorry. Sentinel-2-1. And if we do that, we can see that this is, for example, I will also drag and drop this one. This is from 2022. And this is our base layer, as we say, our reference layer with all the water that's supposed to be there. Here in green, and in purple are the 2022, and we see that, well, yeah, exactly, like a lot of areas water bodies are missing. But this one we don't really look at because, well, it's a bit overestimation regarding the tides. And the same for 2018. You see that overall, yeah, we see the still there are zones missing comparing to the reference layer, but we see that it's much more water present than for 2022. And that's it. That was quite quick. I hope you had enough time to just at least see something. And yeah, again, you can have a full tutorial, and you can slowly, step by step, follow it yourself on your own time, because the video and the file and all the project full files as well provided to you on the website. So yeah, I hope you enjoyed it and learned something new. So if you have questions.
Thanks a lot, Daria, for your presentation. It was really interesting. And for now, we have a few questions for you concerning the tutorial. The first one being a more general question. What type of resolution can you achieve through QGIS?
Well, it does not depend on the software itself. It depends on the products you use in a QGIS. And well, for example, here we used Sentinel-2 image, so we have a resolution of Sentinel-2. EO doesn't have a resolution itself. It's basically just a delineation, basically the contours of water. But again, yeah, it's not QGIS that gives you like a resolution. It's, well, the product you are using.
Thanks. Okay. Another question about the resolution, we will say, can the users analyze pixel data with the help of MATLAB as well in integration with QGIS?
About MATLAB, I cannot tell. I don't think so, but I'm not sure about that. But I think no. But we have Python. QGIS has application in Python. So, for example, there is a Python console in a software itself, which you can use to write your own short scripts, some functions. And also, if you go to when you use some function in QGIS, whatever function you use, you can see also behind that there is a script, there is a code. So basically, it's all relied on Python. So with Python, yes. With MATLAB, I'm not sure.
Okay, thanks a lot. Okay, I will maybe put it on the side just in case. A question about the plugin. What are the advantages of using the CMEMS NetCDF plugin compared to other NetCDF plugins for QGIS?
Well, this, I guess you're talking about the plugin that we actually developed here in Novelties for Mercator Ocean. And what is good about this plugin is that it allows you to see the structure of your NetCDF before you insert the data itself. Because, well, NetCDF is like multi-nested kind of multi-level data, right? So it has like quite a complicated structure. And some plugins, or like, for example, default option in QGIS to add it, it's sometimes not very representative, especially because you just see the layer. For example, you just see the variable, and that's it. And then when you add variable, I think it usually adds as a, for example, if it's a raster, it adds as, well, necessarily if it's raster, yeah, it adds one raster layer in which there are several bands, and each band corresponds to the time frame, which means that you need to add to a project this layer several times, and in each choose your time frame to switch, which is not very convenient. And in this plugin, you open it, you see all the variables you have, you see each variable. For each variable, you see the time frame, so you can choose the time frames. But also, for example, depth if it's for like water or like air column, and like this, you can choose which exact data to add, because if you add the whole like time frame, for example, the whole year, it means that you will have so many bands and you will use only, I don't know, 10, which is not very convenient. And with this plugin, you can actually choose only the data you really need. And you also can add several variables. For example, if you have several variables and you need the same time frames, you can add them like very quickly. So it is very useful tool for that.
Okay, thanks. So a very useful tool.
Yes.
Another question, can we apply the same method to snow cover using NDSY?
I would assume yes. I'm not familiar with this snow index, but I assume as soon as you have bands that are needed for this index, to calculate this index, and you calculate it. Well, you have this representation, as you saw, with water index. I think, yeah, from that, it's more or less going to be the same procedure, yeah.
Okay, good to know. Thanks. So here we have two questions. The first one being, did you calculate the average for both the 2018 and 2022 imageries to reduce bias? And two, does the index you want to calculate tell you which bands you need?
So yeah, for first question, yeah, I forgot to mention it. Now it is mentioned, of course, in a file, PDF file. I just forgot because of a lack of time. We chose only the mid-July of each year of 2019 and 2022, because we know that, for example, 2022, July and August were the most hottest months with most anomalies, and yeah, the summer of 2022 was very dry for many areas, especially for southern Spain. And yeah, and for that we also chose 2018. Like in 2018, we chose the same date. And yeah, to reduce bias, I mean, for that you would need, that's a lot of processing. That's a lot of pre-processing to like have a average of each band of for the like two tiles. It's gonna be a mess. Yeah, it's really a lot to process. And for the second, does the index you want to calculate? Well, not on a WEkEO platform, I don't think so. But I mean, if you need it, you just Google like water index, for example, right? And it gives you which bands to use. There's also like vegetation index, like snow index, and so on. So this information is like out for free.
Okay, thanks a lot for the explanation and the answers. Okay now. What methods were used to validate these results? So,
Well, that's not like it's very, let's say, high-end results. It's just to show you how to use different products of WEkEO platform in QGIS, and also like how to work with different type of data, for example, raster images and vector files. And well, validation here, it's just to like compare with what we have, like compare the in situ data, because well, EU Hydro is it's relying on in situ data and comparing with satellite imagery. So that's just comparison. But yeah, of course, to validate it, you need much more data, much more analysis, more in-depth processing also.
thanks a lot. So we have time for a few more questions. I have seen the hydro area is only in Europe. Is there a possibility to scale it up to the entire globe?
Well, no, because this product is only for Europe. And as I said, it is based on in situ data. So, I mean, it's not like you can really like propagate it to the entire globe for that. So no, unfortunately, no. But maybe there are other products that are covering specific zones in other places on Earth, or maybe will be, I don't know. But yeah, it's true that this one is only for European Union, yeah.
Thanks. Yeah, so we will do two more questions and then we will go to the next presentation. Is it possible to visualize in 3D? I think in QGIS.
Yeah, I don't think so. I mean, you can, for some variables, for example, if your variable is not flat, you know, so for example, here we didn't use variables like that because we have raster image, which is flat. But if, for example, you have, I don't know, temperature, like air temperature or water temperature, it is not flat because it's not only on a, well, on a flat surface, but also in a vertical dimension. You cannot really visualize it. I don't know, like what you mean exactly by visualization, but there are some functions in QGIS I know that allow you to make plots or like distribution kinda in 3D. Yes, but there are not many. I don't think there are many because, well, it's yeah, that's not not the point of this tool, I guess.
And the last question, how to use symmetrical difference to identify increasing and decreasing areas simultaneously?
That's a good question because, yeah, it's true that when we use symmetrical difference, it means that it extracts polygons with zones that are not overlapping. So it means that, either it decreased or increased, so it's either like present in 2022 and not present 2018, or vice versa. And for that, I think it's not, maybe, I'm not sure, but I can look, but I don't think it's symmetrical difference. There's also, there's difference, there's symmetrical difference, there's intersection. And I think for that, only symmetrical difference is actually good. Or maybe actually there's difference. Maybe you can use difference. I don't know. I didn't use that, but it seems like difference tool in QGIS might work because it extracts only like features from the input layer that fall outside or partially overlap with the overlay layer. So maybe you can use this tool and see, and also like exchange like input and a layer and overlay layer. So for example, you compare 2022 to 2018 and you will have one result, and 2018 to 2022, it could be different. It could be different. And like this, you can see if it is decreasing or increasing. That's what I can say very very quickly, but maybe there are more precise tools for that also in a QGIS, or there also could be some plugin which can add some functionalities.
Okay, great. Thanks a lot for the explanation in the live research. Thanks. So we will stop there for the questions. Thanks again, Daria, for the presentation.